Tiwanaku is one of the most important archaeological sites in the Americas. The academic consensus places its founding around AD 100 to 200, with major construction peaking between AD 500 and 900, followed by decline around AD 1000. That timeline is based on radiocarbon dating, ceramic sequences, stratigraphy, and artifacts found at the site. But some evidence has led researchers to ask whether parts of the site, especially Puma Punku, could be considerably older. Puma Punku contains massive blocks of red sandstone and andesite, some weighing more than 100 tons. Among them are the famous H blocks, standardized architectural pieces with flat planes, sharp interior angles, drilled holes, and repeating geometric forms. They appear to have been designed as parts of a larger modular system rather than as individual stones shaped one at a time. Also notable are eye-shaped copper and bronze clamps used to fasten blocks together. Alexey Vranik, whose 2018 Heritage Science study digitally reconstructed parts of Puma Punku, documented the clamp channels and modular geometry in detail. His work showed that many of the scattered blocks could be fitted into a coherent architectural system. The standard explanation relies on stone hammers, abrasives, copper or bronze tools, and large amounts of skilled labor. The question is not whether ancient people could produce sophisticated stonework. Clearly they could. The question is whether the surviving evidence fully explains this level of consistency and precision. The wider Tiwanaku complex includes the Akapana Pyramid, Kalasasaya enclosure, semi-subterranean temple, sunken courts, and Puma Punku. The conventional timeline may correctly describe major periods of occupation and construction during the first millennium AD. A separate question is whether every monumental part of the site belongs to the same period. Arthur Posnansky spent decades studying that question in the early 20th century. He interpreted the Kalasaya as a solar observatory and measured its alignment with the solstice sunrise and sunset points. He concluded that the geometry did not precisely match the obliquity of Earth's axis in his own time. Instead, he calculated an angle of about 23 degrees, 8 minutes, and 48 seconds. Earth's axial tilt changes slowly over a cycle of roughly 41,000 years. Posnansky compared his measurement with the known obliquity curve and calculated an age near 15,000 BC. German astronomer Rolf Müller later examined the measurements. Depending on which observation points were used, estimates ranged from roughly 15,000 BC to 9,300 BC. Those dates place the estimates in the late Pleistocene, around the broader period of major climatic change that included the Younger Dryas. Critics have questioned whether the alignments were intentionally that precise, whether Posnansky identified the correct original observation points, and whether rebuilding, erosion, or later disturbance changed the geometry. Those are not the strongest objections, and the older dates need to be researched further. Modern LiDAR, high-precision GPS, digital elevation models, and updated astronomical calculations could measure the site and its relationship to the horizon far more accurately than Posnansky could a century ago. Geology raises another set of questions. Some researchers have argued that Puma Punku once existed under very different hydrological conditions, including periods when Lake Titicaca stood considerably higher. Huge blocks at the site are broken, displaced, and scattered. Flooding, earthquakes, and other high-energy events have been proposed as possible causes of part of that destruction. Whether those events happened during the Tiwanaku period or much earlier remains disputed. But the geology can be studied independently of assumptions about the site's age. The carvings offer another controversial line of evidence. The Gateway of the Sun and other Tiwanaku sculptures show the staff deity, commonly associated with Viracocha, along with many animal forms. Some researchers have interpreted certain figures as extinct Pleistocene animals, including Toxodon, Macrauchenia, Celidotherium, and even elephant-like forms. If those identifications are correct, they would have major implications for the site's age. Some archaeologists reject those interpretations and see the figures as stylized images or living species. Modern 3D scanning and comparative morphological analysis could test those proposed similarities more systematically. Dating raises a more basic problem. Radiocarbon dating measures organic materials such as charcoal, bone, and plant remains. It does not directly date stone. Radiocarbon dates from Tiwanaku tell us when particular organic materials were deposited at the site. Whether those dates also tell us when individual stone blocks were quarried and shaped depends on the context in which the samples were found. Some early radiocarbon results reached farther into the past, including dates approaching 1500 BC, but were later judged unreliable or poorly contextualized. Newer methods like beryllium-10 surface exposure dating have been applied to Tiwanaku stone surfaces and generally point to Holocene activity, but interpreting those dates is complicated by earlier exposure and later movement of the stones. There is also a separate debate over how the blocks were made. Materials chemist Joseph Davidovits proposed that some Puma Punku stones might have been made using geopolymer techniques, essentially casting reconstituted stone instead of carving every feature from a solid block. That could help explain some of the repeating geometry and internal corners. Petrographic studies has generally supported naturally quarried stone rather than artificial casting, but this shows that the construction method itself needs a closer look. Archaeological timelines do change when new evidence demands it. Monteverde challenged older ideas about when humans reached the Americas. Göbekli Tepe demonstrated monumental construction around 9600 BC. LiDAR surveys in the Amazon revealed dense settlement systems, roads, earthworks, and large-scale changes to the landscape where researchers once expected a far lower population. These discoveries point to an older date for Tiwanaku. They also show something simpler. Archaeological models can change when better evidence appears. The conventional Tiwanaku timeline is supported by some questionable evidence. Sacred cows should not stop specific questions from being asked and tested. What exactly do the radiocarbon samples date? Were Posnansky's astronomical alignments real, intentional, and correctly measured? What events displaced the massive stones at Puma Punku? How were the H-blocks made with such consistent geometry? Were all parts of the monumental complex built during the same cultural period? These questions can be studied without assuming in advance that Tiwanaku must be 15,000 years old, or that the existing timeline must be correct. Science advances by testing its models. Puma Punku is an unusually good place to do that. The stones are still there. The measurements can be repeated. The geology can be studied. The surfaces can be scanned. Modern tools can answer questions that researchers a century ago could not. That is what makes Puma Punku so interesting. We don't know the complete answer, and there is still more to find out. Follow for more ancient history and new discoveries.